So, let us start with our class today. Good morning everyone. Yesterday we had discussed exercise 10.5. Few questions we had discussed yesterday. Now today we shall be continuing from the same page number 184 and 185. We discussed question number 1st, 2nd, 3rd, 4th, 5th and 6th was left in between due to the connectivity. So we will discuss question number 6 again. Check. ABCD is a cyclic quadrilateral whose diagonals intersect at point E. If angle DBC is 70, angle BAC is 30, find exercise 10.5, 10.4. Alright. He says this is a cyclic quadrilateral, so you can see a circle. ABCD is a cyclic quadrilateral. This is a cyclic quadrilateral, any shape. He is not saying square, rectangle, or parallel or anything. He is saying a cyclic quadrilateral. ABCD. What is a cyclic quadrilateral? Opposite angles give the sum 180. That is a property. And what is cyclic quadrilateral? When all the four vertices are on the circle, isn't it? Okay. Then he says, if the diagonals intersect at point E, this is the first diagonal AB, second diagonal AC, they are intersecting each other at E. If angle DBC is 70, DBC, this angle is 70 degree, and angle BAC is 30, BAC, this angle is 30. Right? He says, find angle BCD. So what are the things given to us? First of all, we are given cyclic quadrilateral ABCD in which diagonals intersect at E, diagonals intersect at E, and angle DBC is equals to 70 degree, angle BAC is equals to 30 degree. What we have to find? We have to find angle BCD. We have to find number 1. And if AB is equals to BC, then we have to find angle ECB, that angle ECB. These are the things we need to find. Alright, this is our question. So see students, as I have been telling you since geometry 9th class, it is a very important part. I have been telling you again and again, the important part is your observation. You need to observe the things. Forget, I have been telling you, don't worry whatever they are asking. Find out whatever things you can find. Nothing to worry. Alright. So what is construction? No construction is required. Proof. Observe. Which the angle is talking about? DBC. This angle. So we know that when this angle DBC is on the circle, is this point D on the circle? Yes sir. So this angle DBC is subtending an arc. Which is that arc? DBC. This is the angle. These are the two arms of this angle. So which is the arc? This is the arc DC. Isn't it? Okay. Which is the other angle given to us? BAC. Where is BAC? BAC. BAC. It is on which arc? This arc. These are the two angles given to us, and looking at these two angles, we are looking at the two arcs where these angles are situated, on which arc, on which segment. So here also we will look where is there any other angle on the same arc. Check. First was DBC. This was the arc. Is there any other angle? From D, one line is going towards C. So this is a chord. This is not a problem. This is a segment. Now another line is coming towards A, and from C also it is coming to A. So is this angle also on the same segment of a circle are equal. We know angles in the same segment are equal. Therefore, angle DBC is equals to angle DAC is equals to angle DAC is equals to how much? 70 degrees. Right? Which is that segment? CD. Okay. Then which angle is talking about? Angle BCD. So where is BCD? Or one more angle is given, BAC. Where is BAC? BAC. Any other angle on this arc? Yes, BDC. This one. This is also 30. And angle BAC is equals to angle BDC is equals to 30. These are same angles in the same segment of a circle are equal. BAC and BDC. So this is one. Now what is it telling us to find? These are the two things we could find out. Now whatever he is telling us to find, he says find angle BCD. Where is BCD? BCD, complete angle. So take a look. This angle C, is it a part of cyclic quadrilateral? Definitely. If it is a part of cyclic quadrilateral, then the sum of this angle and the sum of this angle, opposite angle, will be how much? 180. So we know how much is angle A. Now we know, what do we know? Sum of opposite angles of a cyclic quadrilateral is 180 degree. So therefore angle BAD plus angle BCD is equals to 180. Angle BAD, that is complete angle, and angle BCD is how much? 180. Angle BAD is made of 70 plus 30. So angle BAD is made of 70 degree plus 30 degree plus angle BCD we have to find. Can we find it out? 70 plus 30, 100 plus 100 comes over here minus 100. So angle BCD is equals to 180 minus 100. 180 minus 100, 80. The first answer, BCD is equals to 80. Right? Then he says if AD is equals to BC, if this side AB is equals to this complete side angle is 80 degree. Then he says if AD is equals to BC, find angle ECD. ECD. Only this part. Only this part. The complete angle was 80. I want only this part. To observe this triangle. Which triangle? ABC. Is it an isosceles triangle? AB is equals to BC. So therefore opposite angles are equal. This is 30. So this is also 30. In triangle ABC, AB is equals to BC given to us. So therefore angle BAE is equals to angle ECB this angle he wants us to find. Yes. So ECB is equals to how much? 30 degree. This is 30 degree. So therefore ECD will be how much? From 80 we will subtract. So therefore angle ECD is equals to 80 minus 30. 80 minus 30 is how much? Clear? That is 50. I hope it is clear. Because complete angle was 80, from 80 this is 30 subtracted, this angle is subtracted, so the remaining angle portion is left how much? Clear? So this question yesterday we were doing, we were stuck. You can also see it in the video also. Take a look at question number 11. Question number 9. They are on the same property. Only thing you have to do is to observe. question number 9, if you observe, figure looks very difficult. But if we draw the figure and if we do it on our own, we'll be able to find that it is most simplest question. I will not solve. We will just discuss it over here. Take a look at this question number 9. What does he say? He says, in the two circles intersect at 2 points B and C. Let me draw. This figure seems complicated, so let me draw. This is one circle. This is another circle. Both of them are intersecting at B and C. Right? Okay. Then he says, through B, two line segments ABD and PDQ are drawn. ABD, this is A, B, and this is D. Another one is PDQ. This is P, B, and Q. Right? So as soon as we see, before completing the question, what can I observe? So I can see that these two line segments are intersecting at a point. So will the vertically opposite angles form be equal? Definitely, sir. There are vertically opposite angles. This angle is equal to this angle. I name it as X and X. Yes or no? Okay. Then what does he say? Then he says, drawn to intersect. A, P, D, Q are drawn to intersect the circles at A, D, P, and Q. Okay. Prove that angle ACP is equal to QC. What we have to prove? We have to prove angle ACP is equal to angle QCD. Right? Observe. Where is ACP? A, C, P. Now, before that, just check. These two angles were equal. B is a vertically opposite angle. Now, where are these two angles? On the circle. On which arc? Can you see? They are in this arc AP. And it is on this arc DQ. Yes? Both of them are different circles. Now, angle ACP. As soon as we draw it, we are able to identify the relation. Can you see angle ACP? Is it also on the same arc as angle PBA? This was X, so this is also X. Right? And another angle QCD. Is it also on the same arc DQ? So this is X, this is also X. So are these two angles equal? Both of them, when we draw the figure, it becomes easy. Until and unless we draw the figure, we think that the question is very, very difficult. Okay, take a look at another question of the same property, question number 11. Again, ABC and ABC are two right triangles with common hypotenuse AC. Two right triangles are there. This is one right triangle. Say ABC and ABC. A, B, C. This is the right triangle, and A, D, C. This is the right triangle, and it has a common hypotenuse. So this is the common hypotenuse. He did not say it is cyclic or not, but I know it is cyclic. So why opposite angles are giving me the sum 180? That means the vertices are on the circle. Yes or no? So in other words, I can say square, rectangle. Both of them are cyclic quadrilaterals. Why? Because they give the sum 180. Opposite angles give the sum 180. Right? He says, prove that angle CAD is equal to CBD. Let me complete the figure first. He says, prove that angle CBD is equal to CAD. CAD. Let me complete it. Since the opposite angles are giving me 180, that means they are the vertices. It is a cyclic quadrilateral. Now once I draw it, no, my question is solved. How? He says angle CAD on which arc? CD. This angle equals to angle CBD on which arc? Again on this arc. So are the angles in the same segment equal? We proved it. We used it over here. we use it over here. Angles in the same segment of a circle. Both these angles CAD and CBD, both of them are on the same segment. So theorem number 10.9. Angle in the same segment of a circle are equal. Angles, we know angles in the same segment of a circle are equal. I hope you can do this. It is not difficult. Take a look now, question number question number 11, now 12th is left, 10th is left, and question number 7 and question number 8 are left. Take a look at question number 7. If the diagonals of a cyclic quadrilateral are diameters of the circle through the vertices of a quadrilateral, prove that it is a rectangle. Just opposite of this. Right? Just opposite of this question. He says, prove that if the diagonals of a cyclic quadrilateral, question number 7. If the diagonals of a cyclic quadrilateral, this is a circle, right? And these are the diameters. This is one diameter, one, and this is another, right? This is the vertex O. If the diagonals of a cyclic quadrilateral, so that means if I join it, it is a cyclic quadrilateral. A, B, C, D. We need to prove that it is a rectangle. We need to prove that they are the vertices. They are the vertices of a rectangle. So what we need to prove? Right? What is given to us? We are given diagonals AC and BD of a cyclic quadrilateral are diameters of circle. What we need to prove? We need to prove that ABCD is a rectangle. This is what we need to prove. ABCD is a rectangle. So what are the properties of it? Number 1, rectangles, opposite sides are equal and parallel. Number 2, diagonals of rectangle are equal. Number 3, the vertices are 90. That is what we need to find. Yeah. So I am giving you this as a homework. You will practice it and let me know. Only 2 questions are left, 3 questions are left that we will be discussing in the previous class. For the time being, we will stop over here and we will discuss any problems you are having. Thank you.